Welcome back. We are still talking about complex numbers in trigonometric form. So complex I, trig form means we've got this cosine and sine in there. So dealing with powers of complex numbers, we have a very helpful theorem, DeMoivre's theorem. So it says if we are given any complex number, if it's in trig form, and a natural number n, if we want to raise that complex number in trig form to a power, we have a shortcut way to do it. So in that last example in the previous video that we looked at right before this, we said, well, we could multiply them first. But here, in this one, if we had this and we wanted to raise that to the 10th power, is that something you want to do? Do you want to say root 3 minus I times root 3 minus I times root 3 minus I? Of course not. Nobody wants to do that. That's ridiculous. So what we're going to do is we're going to convert this number into trig form, and then we'll apply DeMoivre's theorem by raising r to that 10th power and then multiplying the arguments by 10 each. So here we have the square root of 3 minus I raised to the 10th. And this trig number, or this complex number, we've already converted it to trig form in the 2 videos before this. So I'm going to pause and write my workout because you would have already done this, and if you're taking notes, you've already written this in your notes. You don't need to write it again. So we have our a and our b, root 3 and negative 1. We know that r equals the square root of the sum of those squares. So that gives us that my r value equals 2. Using that 2 r value, I'm able to set up cosine as a over r, sine of theta is b over r, and we're able to conclude using unit circle logic that theta is equal to negative 30. So this complex number in trig form is 2 times cosine of negative 30 plus I sine of negative 30. And we want to take this complex number and raise it to the 10th power. So my n value here is 10. I just went ahead and slid that over. So by this theorem, by DeMoivre's theorem, we're going to take r2, raise it to the 10th, and then we'll have cosine of 10 times negative 30 and 10 times negative 30. Now I could have used a lot of different angles here. There are infinite coterminal angles to negative 30. There's negative pi over 6. There's positive 330. There's positive 11 pi over 6. Why did I pick negative 30? Because it's the smallest absolute valued number, easiest number for me to deal with. It's just going to help my computations. So by DeMoivre's theorem, as I just said, this is going to be 2 to the 10th. And then we'll have times cosine of 10 times negative 30 plus I sine of 10 times negative 30. So 2 to the 10th, that is 1024. And then I have cosine 30 times 10 is negative 300 plus I sine of negative 300. So this value right here, this represents the square root of 3 minus I raised to the 10th power. And again, it's admittedly much faster than trying to FOIL this out 10 times. So we just converted it, which is a pretty quick conversion. And then we apply this theorem, which is to take the radius, raise it to that power, and multiply each of those arguments by that power. So that concludes this video. We have one more video in our trigonometric complex numbers series.